All right, Lily, this is lesson 2. This is one of the easier lessons we'll do this year. It just introduces a new method to multiply polynomials. So, in the example that's on the screen now, in the past, probably done the distributive property. So x times x is x squared, x times 7 is 7x, and then 8 times x is 8x, and 8 times 7 is 56. Combine your like terms, and we get x squared plus 15x plus 56 as our final solution. So the method the module is showing you is called the tabular method. So I have a 2 by 2, so 2 terms by 2 terms. So I'm going to set up a 2 by 2 box. One of the polynomials is on top, the other is on the side. And then I'm just doing the same thing. X times x gives me x squared. 8 times x gives me 8x. X times 7 gives me 7x. 8 times 7 gives me 56. And then I am just combining like terms. So x squared has no other term. 8x and 7x are alike. They give me 15x. And there's only one term with no variable. That's the 56. And I get the same answer as I would via distributive property. Now this looks very similar to lattice if you learn multiplication that way. So it might appeal to you in that manner. So if I have a 3 by 3, I'm going to set up a 3 by 3 box. X squared, 3x, and 1, x squared, negative 5x, and 2, and then multiply. So x squared times x squared is x to the 4th. 3x times x squared is 3x cubed, and 1 times x squared is x squared. Negative 5x times x squared is negative 5x to the 3rd. 3x times negative 5x is negative 15x. 1 times negative 5x is negative 5x. And finally, 2 times x squared is 2x squared. 2 times 3x is 6x. 2 times 1 is 2. I only have 1 x to the 4th term. My like terms for cubes, 3 minus 5 is negative 2. My like terms for squared, 1 minus 15 is negative 14, plus 2 is negative 12. My x is negative 5 plus 6 is just 1x. And then I only have one constant, it's 2. Your final solution would be x to the 4th as 2x cubed as 12x squared plus x plus 2. If I distributed it out, I would have those 9 monomials in order. Distributive property. So then I just have to combine like terms. This is kind of more of an organizational method, so whichever you prefer, you can go with. I'm not bothered either way. With this one, depending on how your organization is, I can do it one of 2 ways. I can do a 3 by 2. And then multiply them out. This is a little different. I have an x to the fourth. I only have one 3x cubed. I have an x squared and a negative 2x squared, so I get negative 1x squared. Sorry about that. I only have one x term, and I only have one constant. So when I'm multiplying not the same numbers in each, so a 3 by a 2, it can be a little more different, a little weird looking to figure out. As long as you keep track of your like terms, you're good. Or I can make it work out nice and neat. By adding in a placeholder of 0x, because there's no x in that second polynomial. It's just x squared minus 2. So now when I multiply it out, I include my zeros. And then I can go straight diagonally. So organization-wise, it looks a little better with the 0x, but if you're comfortable doing it without the placeholder, you're going to get the exact same x to the fourth, 3x cubed, negative x squared, it's negative 6x, negative 2 that we got right there. So finally, this allows us to kind of generalize patterns. And I want you to do this using the distributive property and combining like terms. So in exercise 3, I would have my x's first, so x to the fourth plus x cubed y plus x squared y squared plus xy cubed. That's multiplying x by everything, and then multiplying negative y by everything. Negative x cubed y minus x squared y squared minus x y to the third minus y to the fourth. So that's multiplying negative y by everything. And then I look for like terms. So x cubed y and negative x cubed y are going to cancel out. X squared, negative x squared y squared are going to cancel out. Xy cubed and negative xy cubed are going to cancel out. And I'm just left with x to the fourth minus y to the fourth. So the generalizing of the pattern is that when I have x minus 1 or x minus y in this case, and we're going by decreasing exponent patterns, everything in the middle is going to cancel out, and I'm only going to end up with my first term and my last term. So x times x cubed, my first term, negative y times y cubed, my last term. Everything is in descending order. So that's just a pattern that you may see. If you don't pick up on it, you'll just have to multiply it out. Tabular method or distributive, either way, as long as you can multiply polynomials, that is the objective of this lesson. So what we did for the problem set on lesson 2 was using the tabular method 2B and 2C. And then number 3, whatever method you wanted to use for the left column. So tabular or distributive, whatever method you want to use for number 3. And those were the homework problems for that one. And that's the end of lesson 2. So again, I'll put up a video of the solutions, or I'll put up a document of the solutions, and then if you need me to go over anything specifically after you've had a chance to do it, then we can go and look at them individually depending on which ones you needed extra help with. And you're almost caught up. Have a good one.